Alright, welcome back. So again, I briefly went over long division. I did example 4 and example 1, so just look over those. Okay. Again, make sure to do example 2 and 3, and tomorrow again I'll be calling on 2 volunteers. Let's go ahead and see synthetic division. Okay. And if you notice, I actually put up the same problem up here so that we see a connection between long division and synthetic division, that there is no difference. Alright, so hopefully you remember what the process is for synthetic substitution was, but if not, then I'm going to go ahead and refresh your memory. Alright, so same thing like long division. With synthetic division, the polynomial and its divisor has to be in standard form. If it's not in standard form, then you have to add zeros. Okay? Because remember, for synthetic division, we only care about the leading coefficients. Okay? We went over leading coefficients way back in 5.2. Leading coefficients are just the numbers in front of the x to whatever power. Okay? All right. So we have x to the 4th. Again, go in order. We have 0x cubed plus 0x squared plus 0x. Because again, we have to go 4, 3, 2, 1, and then my last term is plus 1. Okay. And we're going to divide by x plus 1. If you remember the definition of synthetic division, you have to remember that we only care about numbers. So this right here, you have to actually solve for x. Subtract 1, x is equal to negative 1. Because we only want to see numbers. We don't want to see x. Okay? So here we go. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So again, right here are all the leading coefficients of f of x. Here's going to be what you're dividing. In this term, we're going to be dividing by x plus 1, which is x equal to negative 1. So I'm going to go ahead and fill that in. What's the leading coefficient here? It's 1. Here is 0, 0, 0, and 1. Okay. Remember with synthetic division, we're multiplying on the outside and adding on the inside. In order for this to work, you always have to bring down the first term, so that you have two numbers on the outside, and then we could go from there. What is this called? This is going to be your r of x, also known as your remainder. Okay. And since this is the same problem like number 1, okay. If you look, this is the same problem. You already know the answer. So if you look back in your notes, the answer right here should be 2. If this is not a 2, that means there should be a 1 here. If this is not a 1, that means you did something wrong. Okay? All right, so let's get back to this example. So once you have two numbers on the outside, go ahead and multiply. So negative 1 times 1 is negative 1. That goes here. And now you have two numbers inside, so go ahead and add them. So 0 plus a negative 1 is still negative 1. And now you have two new numbers on the outside, well, one new number. Negative 1 times negative 1 is positive 1. Go ahead and add 1 plus 0 is still 1. 1 times negative 1 is negative 1. Negative 1 plus 0 is negative 1. And negative 1 times negative 1 is positive 1. And voila, magic. 1 plus 1 is equal to 2. Okay, so we did this correctly. Now, if you look back at your answer, we have something else in front of our answer before our remainder. Okay? So this is why synthetic division is important, because now we're going to be able to factor and actually find all the zeros using synthetic division. So that's why I emphasize when we're doing synthetic substitution that synthetic division is very important. Okay? All right. So since we're dividing something to the 4th degree polynomial by something by the 1 degree polynomial, because there's a 1, okay? If we're dividing something by 4 by a degree of 4 minus a degree of 1, you subtract those two, this one right here is going to be degree 3. So this is 1x cubed, okay? Because I just made it smaller. By how many degrees? By a degree of 1. So 4 minus 1 is 3. Then you just go in order from there. This will be negative x squared. And again, you don't have to write this one. I just leave it here. I'll just put it here too so you see the numbers. Plus 1x minus 1. And if you look, this is the same answer that we got in problem number 1. Okay? But we're still not complete. We have to write our final answer. So let me go ahead and erase this. So this is our quotient plus positive 2 over my divisor. But you don't write negative 1, just negative 1. You have to write it the way it was originally given to you, x plus 1. And if you see, we get the same answer. Okay. So again, if you like synthetic division, go ahead and use it. But again, it doesn't work all the time. Make sure that the degree here has to be a 1 in order for it to work. If it's not, then I'm going to force you to use log division on your test and on your quiz. Okay. Alright, so again, if this is a bit confusing, okay, or if you forgot how to do synthetic substitution, we're going to go ahead and do another example. Alright, so let's look at the slide. Let's go ahead and do... Alright, let's go ahead and do number 7. Okay. I'm going to have you do 6 and 8 for your homework. So we have x cubed plus 4x squared minus x minus 1 divided by x plus 3. And again, if you notice, there's a degree of 1. Alright, so let's go ahead and use synthetic substitution. So create your L shape, I don't know what you call this, chart, I guess. And remember, this number is going to come from your divisor, but you have to actually solve for it. So x plus 3 equal to 0, subtract 3. So x is equal to negative 3. So negative 3 goes on the outside. Remember that we're multiplying and adding on the inside. Okay. So how many leading coefficients do I have? Well, just count. 1, 2, 3, 4. And it is in standard form, so I don't have to add any zeros. So here is going to be 1. Here is 4. Here is negative 1. Here is also negative 1. And remember, this is known as your R of x, also known as your remainder. Alright, so in order for this to work, remember that you have to bring down your first term. And now we have two numbers, so we could begin multiplying. So negative 3 times 1. Negative 3 times 1 is negative 3. 4 plus a negative 3 is still 4 minus 3, which is 1. 1 times negative 3 is negative 3. Negative 3 plus negative 1 is negative 4. Negative 4 times negative 3 is positive 12. And 12 minus 1 is 11. Okay. So yes, you use synthetic division, but still, this does not give me an answer. You have to know what this means. Okay? So let's look at our original problem. We're taking a cubic function, or a cubic polynomial, okay, and we're dividing it by a linear polynomial. Okay? So 3 minus 1 is 2. So this degree right here is going to be 1x squared. And then you go from there. Next one's going to be plus 1x, then it's going to be minus 4. Plus your remainder, which is 11, over your divisor, which is x plus 3. And this right here is your answer for synthetic substitution or synthetic division. So again, hopefully you're getting a flashback of synthetic substitution, okay? if this is confusing again, watch the video, play it over, so you understand where these are coming from. Remember, you're dividing something that's a degree of 3 by a degree of 1. So 3 minus 1 is equal to 2. That's how you get the degree here. All right. So again, I just completed examples 5 and 7. So go ahead and do 6 and 8. And again, same process like always. I will be calling 2 volunteers to come up to solve these for us. Okay. All right. All right. So this is a little bit different, but not really. We're still doing either long division or synthetic division. It just depends. You have to look at what's given to you. Okay. But this case, we're actually going to factor the polynomial out completely. Okay. So we have to do a little bit more work. Okay. So this is going to bring back stuff that we learned in section 5.4, which was factoring polynomials, plus what we learned way back in chapter 4. We're talking about factoring quadratic functions. Okay. All right. So let's go ahead and begin. We have f of x is equal to x cubed minus 4x squared plus x plus 6, and I'm given x minus 3. Okay. So if you notice, I have a degree of 1. So bells should be alarming in your head, okay, that you could use synthetic division, or you could also do long division, whichever one you prefer. Okay. I preference synthetic division, so I'm going to go ahead and do synthetic division for you. All right. So let's go ahead and add a 0. Add 3 to both sides. So x is equal to 3. So 3 is going to go on the outside. And let's look at my original polynomial. Is it in standard form? 3, 2, 1, 0. So it is. So I have coefficient, my leading coefficient here is here. Leading coefficient here is -4, 1, and 6. Sorry. And again, this is known as your remainder. Okay? But let's think about this for a moment. The directions say factor the polynomial completely given one of its factors. Okay? If they're telling you that the polynomial is factorable, okay, hence you should be thinking about it. This remainder should be 0. Okay? Because they're already telling you that it's factorable. They actually gave you one of the factors, x minus 3. Okay? So you should be able to find the other 2 factors. And how do I know there's 2? Well, it's a degree of 3, therefore there's 3 factors, there's 3 zeros, there's 3 roots, they all mean the same thing. Okay? If they give you 1, 3 minus 1 is 2, so you have to find the other 2 formulas. Okay? So your answer should be 0. If you don't get a 0, you did something wrong. Okay? So again, multiply and add. Bring down the first term. So 3 times 1 is 3. -4 plus 3 is -1. 3 times -1 is -3. -3 plus 1 is -2. -2 times 3 is -6. And voila, what do you know? We get 0. Okay. So we have to use what we just learned on the previous slide. How do we factor this out? Well, we can't factor numbers, and we have to actually have terms in there. So if you look at your original polynomial, okay, you have a power of 3, and we're dividing by a power of 1. So 3 minus 1 is 2. So this becomes x squared minus x minus 2. And I know this is equal to 0 because it's factorable. All right, so let's go ahead and factor this out. So let me go ahead and put it in the middle. And again, which method does Mr. Murr like? He likes box method. So we're going to go ahead and do box method. Okay? Just for good practice. But moving forward, sometimes I'm just going to use mental math because you should have seen, okay, box method a lot of times up to now. Okay? So, if you forgot box method, remember, first term goes here, last term goes here. When you cross multiply, we want to check that our answer is negative x. So this is our goal. If we do get negative x, these are our factors going horizontally. And if you look at the question, that's what it's looking for. We're looking for the factors. All right. So how do we get x squared? It's x times x. And how do we get negative 2? There's two ways. We either get 1 times negative 2 or negative 1 times 2. Okay. So if you look at this number, it's negative 1, therefore negative 2 has to have the negative. This one has to have positive 1. Okay. Cross multiply, we get negative 2x plus 1x gives me negative x. And now you found your factors. So what is my answer? My final answer is x plus 1 times x minus 2 times, there's one missing, look back at what's given to you, x minus 3. And that is your answer for factoring this polynomial. Okay. Alright, so again, I'll continue on the next video. That will be part 3, and hopefully we get to finish the lesson. See you.